This video will help you review the concepts that are involved in simplifying algebraic expressions, that being the distributive property and combining like terms. We first looked at the distributive property by examining the idea of two kids wanting to go to the movies. At the movies, the tickets cost $12 and popcorn costs $4 in our little imaginary movie theater. So I asked how much it would cost for two kids to go to the movies. Well, some of you said each kid is going to buy a ticket and some popcorn. So if two kids are going, I could think of it as 2 times 16, which gives me 32. Others said you could also think about it as 2 tickets and 2 popcorns, which is also equal to 32. This illustrates the basic fundamental idea of the distributive property. If a number is multiplying a quantity in parentheses, it's the same thing as if I multiplied each of those terms by that number. Let's say we didn't know how much the tickets were going to cost, so we're going to call that X. And we didn't know how much the popcorn was going to cost. We're going to call that Y. Regardless of the theater we go to and how much those things cost, I could still think of it as 2 times the cost of popcorn and tickets, or tickets and popcorn in the right order, will always be the same as 2 tickets and 2 popcorns. I can multiply 2 by each of these, distribute the 2 over each of those quantities. This is really important in algebra because since I have an X and a Y, they are not like terms. I can't combine them. I cannot simplify what's inside of the parentheses. So in order to get rid of those parentheses, I have to use the distributive property. It always works the same. If I say 3 times X plus 4, that is the same as 3 times X, which we always write as 3X, plus 3 times 4, which is simplified as 12. Sometimes the expressions are a little more complicated, though, and that involves a review of the whole notion of like terms. If I have 2 x's and I add them to 3 other x's, it is 5x. This is no different than 2 apples and 3 more apples are equal to 5 apples. And we know this is true because in algebra we're always looking at things that would be true no matter what number I plug in for the variable. So let's just pick any number. Let's say 4. 2 times 4 plus 3 times 4 equals 5 times 4. And let's just check. That's 8 plus 12 equals 20. Of course it's true. And it's true no matter what I plug in there. Another way to think of that is 2x is x plus x, and 3x is x plus x plus x, so I have 5x. That's the notion of like terms. I can recognize like terms by covering up the coefficients. Let's say I want to get rid of this coefficient and that coefficient. Is what's left exactly the same? Yes. So I know they are like terms. That is the definition of like terms, Mary style. Obviously, it's not the technical definition. Sometimes we have problems that involve both like terms and parentheses. So let's take a look at what that is like. Say I have a problem that says 2 times, I don't want to put that there. I want to have this be 2 times x plus 5 plus 3x. Anytime I have a problem that involves both parentheses and other numbers, I need to first get rid of the parentheses using the distributive property. Distributive property. And we know that the operation that goes with that is multiplication. And then, after that, I'll be combining like terms. One of the trickiest things is remembering what things go with the distributive property, recognizing it's always the number right outside of the parentheses and the quantity within the parentheses that we're talking about with the distributive property. Since this isn't involved with that at all, I'm just going to bring it down before I even start. From the distributive property, we know that this is the same as 2 times x plus 2 times 5. Now, I can combine like terms, and these are x's, so I know that I'm just going to add. This is 5x plus 10, and that's it. I can't go any further because 5x and 10 are not like terms. 10 is called a constant as opposed to a variable. 5x is a variable term, and so it's not like terms with a constant. Therefore, this is our final answer, and that's it. One more example that gets a little bit trickier would look like this. If I say 3 plus 2 times, I don't know, x plus 7 plus 3x. The first thing I want to do is get rid of the parentheses. This has nothing to do with it, and this has nothing to do with it. So that makes it 2 times x is 2x. 2 times 7 is 14. Now I'll combine the like terms. That gives me 5x plus 17. So that's it. That's just a little reminder on how to do this.